So, hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 152, and in this video we continue with our repetition of the keywords, but not only repetition, we extend our knowledge at the same time. And in my last video I stopped with the try catch block. We have not finished it, so we will continue there a little bit more. And like all time, I will read here a question. You should pause the video, try to answer it as good as you can, and then compare it with my answer. And my answer is actually also not that perfect. I will indicate it only here and then refer to the CPP reference comp site. And I hope you know it by now, it's just a simplified version of the official C++ documentation. So if we understand this one here, we will understand the official C++ documentation as well. And that is our goal, so that we can in future research all keywords and all what we know about C++ in the official documentation. So we get, it makes us a little bit more correct or more secure, or what you want to call it. So anyway, let's get started, I think. And we start here with the number 70, and the number 70 says, what is stack unwinding in context with try catch block? Research online. I said here in context with try catch block because stack unwinding is a general term, can be many other things as well, because the stack, like we know, is just a place, a virtual memory in our RAM, which is read access memory. And yeah, that's why I said here in context with try catch block. So only this, we are only interested in this context here. All right, try to answer this one, and I will now continue, of course, with the to answer this one. And because this one is a very complex thing, I will probably not write here a direct answer. I will just refer or say something later. But let's get started first. First of all, where I can read this. For example, you can read this online everywhere actually, but of course I will use this documentation here. I go here to the throw expression, and the throw expression, when you scroll down, it has here stack unwinding, a little explanation. And when we go here through, the problem is there are many words which we don't know, and there are also many things which we have to know normally to understand it correctly, which means we will skip some parts. We will only concentrate on some parts, which is primarily the first block here. And the other things we will not, so let's say we will skip them a little bit, because you have to understand about constructors, destructors, and we have not talked about this kind of stuff, because constructors and destructors are needed when we talk about classes, and we have not talked about classes yet. So with that said, what is stack unwinding? Of course you can read it here on your own. I will not read here anything, or you have searched it online and there are many good answers, or C++ books. They will explain it all in a way perhaps better than this one here, because this one is a little bit complicated. And that's why, because it's so complicated, I will make an example here and then explain it with an example, because starters need examples to see it. It's easier with examples. But before we go to the example, I have here a site which we will talk about this diagram. But what is this site before? This site is a Stack Overflow site, and I asked here what is stack unwinding, and they have here different answers here. Here you can see one is answering this, this, and this, and yeah, they are good. These are good answers, but in our case I will still stick to this one here, to this block here, and I will make an example, because that's I think we should still orient we should still make an orientation for this documentation. That's very important for me. So, but why I'm showing you this one? Because here is a nice diagram. Why is this nice? Because it's easier to explain some things here before I make an example. My goal is later to make an example like this diagram here. And that's why I'm showing you this one. So what we have here, watch this diagram here and watch this diagram and try to understand it first. You can pause here shortly the video, try to understand it. I will explain it then. All right, if you understand, this is the first diagram, this is the second diagram. And what the important thing to understand here is that this red line goes here back and this red line is not going back. Important info, here is no throw. Here is a throw. And now if you understand this diagram is good, because then you researched already very much. If not, no worry, I will explain it. And one more thing, this diagram here is, yeah, it's not really showing some details which are very important, which I will show later in our example. But this diagram has not the goal to show all details, right? So what is this diagram showing at all? First of all, we have here our main. This is our main block. And then we have here a try catch block. And then this try block where we try the code, he start to test, he start to call a function. And here you can see this is a function call. He calls it here. And this function body here is calling another function. And this function body of this here is calling again another function. And this function here is the last function. And this last function has only an throw exception. But in this case, this throw exception is not executed because there was perhaps no errors, or there were no an error. Do I know what I mean? And then it's returning. Returning means after this scope here with this curly braces here down, it's finishing this body and then it's going back. That's very important here to know. This function is going back to what? To the caller and finish the callers and go to the next line. So this function was called here. It finishes, goes back. The caller is finished to the next line. After this semicolon, right? It would be jump here. And that's very important to note here. And then this function body for this function is going on, and you can see it will continue here, and then here it's finished. And then after it reaches this curly braces here, it's going back. And again, very important to this caller again, after this semicolon, it will go to the next line here, or after the semicolon here. And then the same goes here, and we are here at our try block, and we are here in next. So that was this one. And what happens here in the second diagram? In the second diagram, it's the same thing what I described. The only difference is it's called the function, it's calling, the function, it's calling, the function, it's calling. But here, this throw exception is executed. And what happens then? And this arrow is right, but it is not showing some details, which is also very important to know. Actually, after this one here, this arrow here, it's going down here. It's going back to this one actually. But this arrow shows here. So who is right, this arrow or is my talking right? So the point is, this arrow here, he made a shortcut because he said this arrow, this throw here is trying to find a catch block, and he has not defined here a catch block, and he has only defined here this catch block, and that's why he made here an arrow like this one. Normally, but that's why I say I need an example. I make a similar example to this one, and then I show you what happens in real. In real, this here is going back to this one here, and then it searches here a try catch block, or let's say it searches a catch block, not a try, a catch block more, because this one is executed this throw, it tries to find it, it will not find it, and if it's not finding, then it goes to this one, and then it tries to find here a catch block. If it's not finding, then it goes here, and here it is finding, and that's why we have an error here. And that was only the missing information in this one here. So if you notice, when I said stop the video and try to figure this out, if you knew this, that was good. If not, no worry. Now the example comes, because I will make now exactly, I write here a code exactly like this one here. We throw here an exception, and then I show you what happens here. So let's go to the coding section. I'm jumping to this place, and you can see I already wrote here exactly the same thing what we have here. We have here our main. I started here a main, and all the other things I have just commented out. That was the thing what we did in our last video. But here is our try catch block. Okay, here's the try catch block. Here I start a function, here I have a next function, and here I just wrote one more statement, a cout. That's not very important now. And then you can see I have here some catch blocks, and in this case I have a string catch, an int catch, and a general catch. We talked already about these different kinds, right? So what happens then is this function 1 is calling like here, this function 1, and my function 1 is where is my function 1? Here. This is my function 1, and my function 1 has only another call, which is function 2, which is here. This function 2 has another call, which is function 3, and function 3 has in my case only a throw, which means in my case it will definitely throw. It's not so simple, so I can show you the normal flow without this throw, which would means here I can say here, for example, if true, no, if let's say if false, it will if false, make this one here. Normally I want let's make it so if 1 is greater than 3, 3, this is then is false, that will be false, then you execute this one, and so on. Okay. Oh no. All right. So that I simulate just that this one is not called. You can see this is false. I could write normally false too, but this one, it's better for starters to understand it. Then you can see this one becomes false, and if it's false, it will not execute this one here. This one will be only executed if it's true, right? We know this. So, okay, now it is similar to the first block, which means it will never execute this block here, because without this if here, it would, if I just write throw, it will all time throw it. That's why I have just made this one here, so that it's not throwing now. That's the first case, and the first case means it will go back here to the next function, and my next function has nothing. Let's print something out, std cout, and call it, let's write here that next function called, next function, next function, next function called something like that. That's okay. That's not very important. So that's done. I think we can make this. And when I start this, what we expect is that exactly this workflow goes on. So not this one here with this exception. And here is one thing what I wanted to mention as well. And that thing is actually, I told you not to try in one try block 2 things. We will talk about this more, because what is the problem if you try in one try block more things? It could be that the second one is never executed if there is a problem. For example, in this case, here we have a problem. This next here is not executed. You see, it starts with the first function here. It jumps here back to this catch block. To this catch block here. and then this function is just not executed. But we will see what happens in my example, because I will change this example a little bit, right? I use only this diagram to show how this works. So, all right, I start now. My setup, what you see here, is exactly the setup what we have here on top. I created a function, I call this, they are calling da, and then going back. And if I start, what we have is, thanks God, not an error. No, here it says next function called. So that is that is this one here, like I expected. And last statement, this one here is in try block. And let's watch this fast again. What happens here? It goes here, here, here. This was not called. It goes back, back, back. And then finish this one. This catch block is not activated, and then it's finished this one. All right, this all happened. Oops. This all happened here. So my main started, the function called. It goes to this block. This is calling this block. This is calling this block. But here is actually enough. This one is okay. There is no error because I defined this false. So this one is not executed. This is just a simulation that there is no error. Later we simulate there is an error. But what happens then is this one goes back to this caller here. This one goes back to this caller here. This one goes back to here to this caller, and this one goes back to this caller. And then this one here is calling the next function, which means this one is jumping here up. So it's not going here back. This one is going here. It's calling this one here. That's why we have here next the function called. This one is going then back here to this semicolon here and goes here to the next line, which is then calling this last statement, and we have it. And what happens here after this try block? It's also very important. This try block is finished, but there was never a throw catch block, throw keyword, so no exception is thrown, because this throw is indicating that there is an error. But in this, all in this function, there was not one error, which means this try block is just skipping all the catches and goes on here with the normal workflow, which means it's returning to 0. We can make here one more statement to indicate that we are in the main. So we can write here std cout something like, here I caught last statement called. Here also last statement, it's next function called. Here last statement called, it's not so good. Let's write here something different. Let's write here function try block called. Let's write a try block called, and here I write main block called, something like that, so that we can see just where I am. It's not the best naming. It should just indicate that when I start this one more time, that I'm there. So which means I go here, I start here the program again, and now we can see it, right? So it jumps here. You can see after this one here, try block code, that was this one here. When I come back from all the other functions, then it jumps down to this here, and the main block code from here. And why I'm showing you this one here, and that's very important because that is the normal function call till now. So this try block here behaves like a normal function call, normal behavior, normal flow when there is no throw. But when we have this throw here, we have a problem, because this throw, like I said, you can see it, it will try to find a catch block. And catch block means after this throw, the statements will be not executed, because it's just trying to find a catch block. But it means not, it is just jumping here backwards like here. In this case, like I said, here he has only defined a catch block here. That's why he made here an arrow back here, but it is going back. So first of all, it checks here, this block here, is there a catch block? No. Then it goes back, checking, is here a catch block? No. Then checking, here is a catch block? No. And then here. And our topic was what? We are talking about stack unwinding. What has this now to do with stack unwinding? The stack unwinding here means, but let's make here it before, let's talk about stack unwinding here in this example here without this throw, because this one here is another step, another level. Oops. Let's talk about this one here. That unwinding means here, when we read here a little bit, if you read this a little bit, then you can see that it is let's what's called, so how I say that, it is let's see, the memory which is allocated will be freed. I hope you read a little bit about memories. If not, no worry. It means just that this all the variables which we have here defined, it should be later, after this block here, destroyed. And destroyed means it should be cleaned up. It should be the memory which was allocated should be freed. And stack unwinding is doing that. And so which sorry. So in the normal flow, for example, after you finish this block here, this function block here, we have not really talked about we have talked a little bit about the scope, right? And I said, when you finish the scope of a function body, for example, after you finished it, all the variables in this scope will be destroyed automatically, because this is the automatic duration, or the automatic variable duration, for example, and so on, which means they will be handled automatically for you. You don't have manually to free this memory. We have not talked too much about this, but the problem is exactly that is stack unwinding, because here in this case, it freed the memory for you. It goes here back to this function. After you are finished with this function here, it will free here the memory for you, and so on till you reach this one. And this one happens also when you use this throw, but there are some problems sometimes, and these problems are more pronounced there. So, but let me go on with my, this is again thing where we have to dive in, yeah, a little bit too much theory, and that can confuse. But what you should know is just this process here. Just understand this example, what I'm doing right now. That's okay, because then you will see, because we discussed now the problem here with this jumping here, because he is indicating that this one here is jumping to the catch block. And what happens now with this other thing here? He is not really telling this here in this diagram, but actually, like I said, this one is going back, and while it is going back here, checking if there is a catch block, all this kind of stuff, what was allocated will be deallocated because there was an exception, because there was an error. So he is yes, the stack will be freed, for example. Then it's checking here, there is nothing, this stack will be freed. Here is no catch, this stack will be freed. Then it's here, and here, of course, he's not going here, he checks this block here. If here is a catch, then it jumps to the catch, and till this point, all the stack is freed. So this information, this very important information, is not here. And you can read it here. It is more or less in this first block. And there are some more other complicated things with destructor and so on. This one we skip, but there are some problems where the stack unwinding can't happen. Let me show you this in this diagram as well. Like I said, when it goes back, it is freeing all time the memory till it finds a catch block. The problem, what they say is, if this throw here can't find a catch block, because this throw only works with a catch block, there will be no stack unwinding, which means this variables here, this variables here, this variables here, and this variables here are not set as handled, as also the memory is not really free, and this is anyhow how here on the bottom of this line here, so you don't have to read all this constructor things, just read here the bottom line. There is the problem when it's not possible to go back. And we will make now an example. That was a little bit theory, so you should read this again. Of course, you can find a better online C++ book or something else where it is a little bit more explained in detail, but I explained this one now with an example, what I told you right now. So what we have here, right now I showed you just the normal try catch block without an arrow, which means without an arrow, this try catch block works almost normal, which the only exception is after this try block, it is not coming here. These catch blocks are reserved for this throw keyword. So now I want throw an arrow, and in my case I just right now here this one, let's make this one less, and now this one will throw an arrow. And one more hint, if it's frozen arrow, it means there is something went really wrong, which is not related to code error most time. Which what I mean is here in my example, in my other example, was it better? I think yes, it was better there. Let me show you this one here in my other example, because here I can show you this one, explain it a little bit better. Control uncomment fast. So that was my other example, which you probably know. I made here this try block. I said this telephone number must be 1, and then I said anyhow that this telephone number is changed to this value. What I told you, there was one thing what I not told you. This line here exists not in your code. So this was, I said this was changed, yes, to this telephone number is anyhow changed, but it is not possible through your code, and that was what I missed to tell you. But the problem is now this line is not existing, which means but this code is still, this number of the value is still changed. And then I said you can check this variable, for example, and then throw an exception, because then the programmer should come and check why the hell this what is the reason that this telephone number can be changed even there is no assignment operator here. For example, normally you can change this only here at the start where you can declare it, but this is the point where it declares, and this line code exists not. Let's say, yeah, that's why I wrote here simulation. This one offline code exists not in normal case, but anyhow this code was changed. Anywhere, anyhow, it was changed, and that's why it is an exception. It is not expected from the programmer, because there was normally no way. And a real world scenario would be, for example, a hacker get the source code, he got to this line here manually with a editor and change this value here, for example, to 54433. That's possible. And then this value is indeed changed, but you can see it has nothing to do with the code itself. The code was right. For example, he entered this code, you probably know it, you can open up the source code and then change your values with some cheat programs, and then this value is changed. And something like that, we need this check here. The problem is, the problem here is, if something like this happens, you have to decide, is this error handle, if this error, can you solve this error at runtime? At runtime means while the program is running, or should the program shut down and the programmer should come and check it manually and find a solution? For example, this one here, normally, for example, in this case of this changing a value, and this kind of stuff happens a lot in single player games, for example, they change just a value. And the solution is, for single players there is no solution, but for online games, for example, this is a real world scenario, they don't throw an exception at all, because that would stop the whole game. They are not doing this. Instead, they are just saying the server has also this if check, and the server decides, should I stop this client who is changing this one, or should I just set this value back? Because let's say the hacker set this value here to 433, something like that, and the server decides later what this value is, and the server says, okay, I don't throw an exception because I can just set it back. My telephone number is back to 1. That's happening most time in online, for example, servers, because they are trying to cheat on their games, on the cloud, on their home games, for example. They go to their lives, make the live from 1 to, you can see now I have 5,433 live, but the server is checking and updating all, or every frame or something like that. Not every frame, but every second or something, and then the server will update this value back to 1, and then you don't need a throw. But that's only a side story. And I'm telling you this side story because you have to decide when to throw an exception, and when you throw an exception, you have to decide how to handle the catch. I have not talked too much about this normally. For example, here I throw an exception. It is a float, this one here, and my float here gives me the line number where the exception happened. Okay, it is in this file here. It is on line whatever here. And it says here my telephone number is not 1, and that should never happen. That's this log file here would normally redirect it to an error log file, which is just a text file and saved separately in a text file where the programmer can come, read this, open up this code and jump directly to this place here, and then check if can make here checks, can check why this happened, if this is happening during this code, or was this manipulated from external codes, and so on. And why I'm telling you that? Because, like I said, you have to decide at this point if you want let the program flow here to continue till now, or with these other examples too here. Till now the flow was more or less here in my other example. You can see we started here, the program runs, it throws an exception, it goes here, and then we continued here, right? But this is not normal. Let's say it's not the normal case, because an exception should be only thrown when there is something really not normal. And when I say not normal, I mean it is not a programmer mistake. It is something happened that should never be happen, and then you want normally stop the program if the environment accept this. Sometimes you can't stop programs, depends on what kind of program do you, but in general you would stop the program. And stopping the program means, go to my other example here, let's say I have to stop now after this exception the program. Let's say it is an error. This is catcher here. My catcher was this float here. He can't handle it. He can show me this error, give this redirects, for example, this error to a text file. I can come later as a programmer and check it. But should now the program go on or not? And that depends on the error. If it's a dangerous error, you have to stop the program, and there are different kind of codes. For example, you can use exit, you can use there are different kinds, abort, you can use abort or something like that. You can use return, is not so good. Return is normally recommended, and most people say you use return something like, because you should go to back to main or something like that, so that the program can handle all resources. But the problem here is this was already a dangerous exception, for example. That's why you want to stop it. And that's why they don't recommend, for example, to use exit or something like that, because they are not cleaning up the resources. But like I said, that's not so the case here, because the problem is perhaps this problem was so, yeah, depends on the problem, but let's say it was danger, right? And if you are going on, you can cause even more problems. Instead of using then return and something like that, you just say stop here, don't go on, doesn't matter of the resources and all this kind of stuff, just go out, or this one, just go out, stop this program. And yeah, that's enough. It's not recommended, but sometimes really the best solution. And the reason for that is depends on the error, what you have. And you come later here anyway and then check this one. All right, that was this one. And let's go back to our stack unwinding. And the stack unwinding was now, like I said, it goes here back and it frees here the resources. It goes back, it frees here the resources, till it finds a catch block. But the problem is, if it's not finding a catch block, it will not free the resources here and we have a problem. And you can read this one here. So I talked so much about this one here, but I showed you not what happens if we find another try catch block here. So that's why I changed my code. But before I change my code, let me uncomment all the other code here again, because this should not run now. So we are back to our functions. How my function was working. Oh, I have not even shown you the throw version, right? Oops. Okay, I show you fast the throw version. The throw version means now my function is running here, is calling this function is throwing. It tries to find here a catch block. There is no catch block. First it tries to find here a catch block. There is no catch block. Then here a catch block. There is no catch block. Here a catch block. There is no catch block. Then here a catch block. Yes, there is a catch block, because here he finds this catch block. Then he checks the type. Is the string type? I have here thrown a string type error. Yes, it says the string type param, which is my cons. We have not talked about it. This one is also string. Okay, then it finds this one. It will handle it here, which means, and here you can see this one is even using the variable. Variable means I can use here the value. The value is here a info text, which I can, yeah, for example, print out here. But normally you would redirect this, for example, to a file, to an error log file in text file, and then the programmer can read it later, or to a log here anywhere, or you can say now you have, at this point you have to decide, do I stop here or I let it go? If the problem, in my case, for example, here I have no clue what the error is. I simulate here an error, which this one is not really an error here. Let's kick this out to make it more clear. Oops, not so. So at this point it is just throwing anything. Right now I don't know what the error is. Now you have to decide at this point, should you go on with this one or not? Can be danger, depends what kind of program you make. For example, if your program is used on a plane, that can be differently danger. Perhaps you can't stop this program. I mean, let's say this exception throws in a plane program. Let's say they have anyway computer program on a plane. You should not stop the program on a plane, because that can cause more problems, which means in this case you would let run it, but you would try to handle it anyhow, right? So you would throw, you go here to the catch, and then it prints out this message, and then you would say, you would try to figure this out anyhow if you can. Most time you can't, because this kind of exceptions, like I said before, are most time not expected. They are not normal errors which you make during programming. This kind of exceptions are most time errors which is really unexpected for a programmer. And that's why they call also exceptions. Okay, let's go on. But there are different types of exceptions. Some are expected, some not. Anyway, we are here. You have to decide, do I stop it or not? On a plane, you would probably not stop it, because then the plane software is gone. But let's say you have I don't know, let's say it runs on a server and there is an error, and you say, okay, the server has anyway a backup server or something like that. You can stop, and the other backup server is starting, and this one should be maintained, also should be controlled. So in this case, let's say if on server, let's write here a comment on plane, don't stop the program. On server, you can stop it because servers got most time backup servers. So that you can decide it here. In my case, because an exception, and most time I will not make a plain program, that's why I say I stop it, and I call here std exit. And exit code, you have to check what this one means. I just write here exit 1 just for fun. I have no clue what this one is. Anyway, probably that there isn't. You can watch this exit code in online what one means. But when I start now this program, you can see this one is jumping here. This one is jumping down here at this point, and then it is just putting out the information, and the program is exited, which means this one is not even called. All right, so far it's okay, but again, what was the stack unwinding here? The stack unwinding was actually this theoretical part, which I can't explain, because all the resources which you have, which I created here, and I have not created many resources actually. For example, I call here function 1, and I can, for example, create here resources. For example, I can declare in this function other variables. For example, int my function variable 1, and I resource this one here, and this one I can copy, paste here, and I can create here resources too. Let's paste this one here too, and call this one here so, and so on. Anyway, that's not so important. Let's make here 2, make here 3, make safe, make here throw, and let's see. And one more thing, don't worry if you understand this kind of stuff with stacks and all this kinds of stuff not right now, because later when you get better and better, you will understand this, and you will even use of course you can use here the this compiler, then you understand it too. But later you will perhaps also use a little bit what was it? There's other no, I don't know it. Assembly, yes, later you will use assembly. I have an hangout right now, I don't know why. Anyway, later you will use an assembly, and I showed you an assembly something like what was this one? I don't know. Online compiler, yes, something like this was. And then we can go here to online compiler. There are different kind of online compiler. Let's write a C++ perhaps. I don't. Here's an online compiler which I use. No, this one I don't use, but that was it not. Where's the online compiler? Anyway, there was an online compiler which I all time used. I don't know where it is. It is really a compiler, not just no, online assembly compiler. I should write online assembly compiler. Online assembly or assembly compiler. Then in C++, perhaps C++. Where is that? No compiler explorer. Yeah, that was it. That was it. For example, if I would put now here later all this code here, and then you can check later this one with this assembly here. And with this assembly, you will see exactly later what happens when, of course, you will need to learn a little bit assembly, but this is for intermediate and professionals because they have to learn assembly if they want or not. You can see this one is anyhow connected. And they have not learned it in depth, but they have to learn it so that they can understand this code, how it is represented here. And then the stack is then shown what happens exactly there. And with that of kind, they will understand this really in detail, find all this kind of errors and more. But we are starters, don't worry, we have not to know this one. So let's go back to this point here. What I want to show you here is, the stack unwinding. So what I want to show you is that all this kind of resources which I created here will be freed. That means and only freed if I find a catch block. So if I don't find a catch block here for this throw, this one causes problems. And I think I don't dive too much deeper because I want to show you something else, which can be irritating a little bit, but let's do it. So what happens if I write here another try catch block? And we learned this. I can go here, right click, go here to snippet. Of course, you can type it on your own too. I'm too lazy. I go here and go here to this try catch block here and right here. And I have now a try catch block. Of course, let's make this catch block I delayed and used the same catch block from here because I'm lazy. I copied just this one here and write it here. And now what happens now? That's an interesting question, but before this interesting question happens, let's put it not in. And later I put this function here in this one, later, not now. Let's put them at least above. Let's put them here and test what happens here. Now I said this throw will search here a catch block, right? I said if it finds here a catch block, then it will use it if it fits. And this one is a string type. This one here is string type. It can catch, but when I start, we see what we see. Now it was the message like before, which means it is jumping here, jumping. I show you this one, what happens here with the debugger. It's better. So I start here, the function is here, I go into the function, it's here, I call it here the function 1. I'm here, I go into it, it executes this one here, I go into it, it jumps to the function 2, bang, here on top, and now it goes here to the function, I go into it, it creates this variable, and now it jumps to the next function, bang, it jumps here on top. And now I go again into it. It creates this variable here. I go into it and now it throws. And we learned when it throws, it will try to search a catch block. And now look what happens. I go into it and it jumps here. And it is the main. So it is not going back actually. I said it's going back. But it's not going back. So it's jumping here to the main, to the catch, and here the string, and then it's executing this one. It goes here. You can see now it finished this one, which means it finished here this output. And I go again in and here, oops, not this one. Yes, and then I'm here in this one and exit, whatever, here. It's finished then. It exits here the code. So when we go back to this diagram, this was right. That looks right, right? But I said, what I said again? This throw is searching in every block a catch block. And here, and here, and here. But anyhow, it's not right. Or I am right, or is this not right? So let's go back to this one and see. Here's a throw, here is a catch block. Why it's not reacting? But this diagram here is right then. But careful. This catch block here, it will only react when you use the try block. The problem is here, I have not used the try block here. So if I would test now this function here free in this try block, let's see what happens then, right? I have not tested this function here. And let's go back and let's see what happens now. The same thing before, without this one, it was jumping down to this catch block here. And now let's do the same play again. I start, all right. I'm here at the bottom edge. I start with the function. I go in. I go a little bit faster. Then function 1 is finished. I jump to function 2. Function 2, it's go in. Now it goes to the try block. And the try block tests function 3. It goes up. And now it's interesting. What happens now? I go in. It creates this function variable here. I go in. Now this throw is important. Before it jumps now down. But I said this throw is searching for a try catch block when, of course, we have to use the try block. And now look what happens. I go in and it is jumping here. And it is executing here. And finished. And this one is okay. And what happens is we have now this execute. Still the same output. The reason for that is because this output is copied here and this one was outputted here. Here, and then we exited here. So, and what I want to show you one more thing. So what I want to show you now is, let's see, what is if I don't use the try catch block here. So I move it again back here. I move it back. And this try catch block here, I cut it out and put it now in test 1. And now I move this one here. Right, now I move this one here. I test function 2. So let's see what happens now. I start again. And we are here again. I go in. It jumps here to the function 1. It goes in. It creates a variable. It goes in the try block. It tests now function 2. It jumps up. It goes in. It goes here in function 3. It jumps up. It goes in. It creates this variable. And now it throws. And look, this is the important part. What happens now? Where it jumps now? Because we learned this throw will search a catch, but important is where. Bink. And we are in function 1, which is this right or not? So you can see this one works also if I try it with function 2. This one is function 2 is tested, and this one is going to this catch block. And yeah, I exit again. It will say again, no found, it's okay. But you see, and that I want to show you only this one, that you keep an eye. This throw will try to find an right catch block when you test it, but must be not the first one which you have defined here. When you test here many tries, it will find the first fitting one. And yeah, I think that's enough for that. I hope you understand this a little bit. If not, no worry. The only thing what you have really to understand is, let me show you that. What you really have to understand is that you can test the code. This try here will connect to a throw, but if you have already tested another code, the last try block will catch it, or it will try to catch it. I have not shown you this one. Oh, I should show you this one more. Sorry, I have to show you one more thing. That's very important. What is if I have here not a matching catch. Let's say this one is just char, not const char, it is just char type. What do you think what happens now? Because here it jumped to this test one. Let's start it before I talk too much. I already talked too much and see it. So it is here again. It jumps to function. This goes in. Function 2 will be tested. It goes there. It goes here. And now it's important. It goes here. And when I click now here, where it is jumping here. Normally it is tested here, right? But here is no sorry. This will catch it. Sorry, I saw it not. Here is a catch block which will work. All right. I go in, it will go here. Because this catch, like I said, this one catch all types. I forgot. I have to eliminate this catch block. So now again, this catched all type. Doesn't matter if the other ones is not working. This ... matches to all types. That's why it catch. Okay, we start one more time. Let's start one more time. All right, here I go in. Now I jump there. I go here. I jump on top. I jump here. And I'm on my throw. Here it's interesting. So where it is going, here's my try. My try has no matching types. And let's see. I go in and it is jumping to main. And the reason for that is it is still going here, but it checks here and it's it finds not a matching catch block. And then it goes and then it checks the next place, which would be function 1. Function 1 is called here, and then it tries this block here, and here it is finding a catch, and then it's going into this one. Okay, that was that. And now we can do one more thing. So now I can answer this one, and my answer is what is my answer here? What is stack unwinding? A way of source freeing. Freeing, you know what I mean. It's a way of source freeing, and you should understand all that what I understand. And like here again, it goes here back, but when it goes back, it will all time free the source here, free all the allocated source, but there is a problem. When it can't find a catch block, all the source will be not freed. This is the only thing what we should know as a starter, but there is much more. I have not talked about all things here, but as a starter, that's enough. That's enough. If you understand all that, what I explained here in my example a little bit, it's not too difficult. It looks only difficult. And that's enough. So one more thing, we can make one more thing, and this is really the last thing here, the last question, and then we are finished with try catch block. What is a refrow and how we do that and for what? Why is the syntax different? We start here with the syntax, by the way, and yeah, try to answer this one. If you know it, very good. If no, no worry. Now you will know it. We start, like I said, with the syntax here. And let's jump to the syntax, and you see the syntax is just throw. And the other was throw with an expression, and here we use literally throw. Okay, why is the syntax different? I say it. Okay, that's a little bit more difficult normally, but let's say because we just refrow the same exception again. And what does this mean in a moment? Exception again, and we avoid let's see what, and we avoid what we avoid, and we avoid at the same time. That's a little bit complicated. Again, let's make here, because we just refrow the same exception again without copying again. Copying or slicing without copying or slicing. Yeah, doesn't matter if you don't understand the slicing. This has something to do with classes, but we are not. I will explain this in a little bit more in detail. Let's go to the next one. What was it? What is referral? Yes, what is referral? Referral is we just referral. Okay, referral is an exception occurred and we throwing it again. That's referral. And just throw an exception again. I make it short. I will explain this here in a moment a little bit more. And how we do that, use throw. Use throw. All right, we use the throw keyword, but important is here this syntax and this one, and for what we need that, and for what? Yes, to throw again. Let's say for what, that can be tricky a little bit. For what? Because we couldn't handle it. Let's write here because the catch could not handle it in this position, for example. So let's go a little bit deeper in this one again. So normally you have here a throw, and the throw is used for rethrow, and a rethrow is, for example, here I throw it one time in my example with my functions here, right? So my function goes to my try block activates a function, the function goes to this function is calling that, and then I throw this. And what happens now is this throw will try to find a catch block like I showed you before. So it goes to tries to search in this function, there is no, tries to search in this function, there is no, tries to search in this function, and it was also tested, that's very important, only then it searches here, and it goes to the catch block, but it can't find a matching type, which means it is skipping this catch blocks as well. And then it's going to the next function, which is going back here. And here we have found it, right? That's very important. We found it. And instead of exit now, we have to disable this exit here. It goes here. And then I throw this information here as well, because information is this text here. That's why I use here, for example, this string, this variable name here. The variable name is just a string, and I use the value, and the value is this text. But the problem here is, let's say I could not solve the problem here because this throw indicates me it was a problem, but I have no clue, or let's say this catch block has no clue what this problem is. And then you have the opportunity to rethrow it with the throw keyword, if I write it right, throw, but this time only throw. And that's the syntax here, just throw. And interesting is you throw it in a catch block, because normal you would use this syntax for normal throws, and this one is this indicates I take here the exception which comes from here. This throw sends an exception here, this exception object here it's called, or in when we watch here the syntax, it says here expression, but when you go here down it's the exception object, and this exception object is catched then here at this point. In this case it is catched in our catch block here, catch clause here, and this object is exactly thrown again. And why I wrote there something like what I wrote there, yes, what I wrote here, just throw an exception again. Yes, because we take this exception and throw it again. We use the throw. Yes, we use the throw. And because the catch could not handle it, yes, I will explain this in a moment a little bit more. And here, because we just reflow the same exception without copying and slicing this here. Let me explain this one here a little bit. The problem is here when we use, also not the problem, let's say they solved it so that if you use this throw here, this exception object is rethrown like it is taken the first time without any information lost. Because if it's here, at this point, there can be information lost already. Because the point is, let's say here we have a throw and here was an error already. And then it is skipping many things and the exception object is coming here. And if you use now this throw without information lost, it will be thrown again. And that is one thing, but more important is why we throw this again. Normally we have here a catch, right? And the problem is sometimes this catch can't solve it. For example, you try to solve it yes, we can try to solve it like in this example, I don't know. This problem here is, here we have no idea actually. And then you say, at this catch here says, actually, I have also no idea. And then it tries to throw this exception again with the hope that another exception and another catch can handle this one here. And the best thing is I make again a demonstration fast. This one is not good. Let's make it so. Let's write here my std exit, because at this point I want, let's say at this point, this is my last try and catch block. At this point, if this string comes to this point and it's not handled, then I want that this program stops at this point. But I say, if this catch is handled perhaps in one of these other blocks here, then it is solved. For example, let's go here and let me copy this line of code. Let's copy this line of code. I need this line of code here again. Before I made an example that here, this function test2 is tested here, right? This one is tested and this one is thrown. This one will come here and I add here now this one here. But the problem is this catch here is matches this, but it can't handle this one. Let's go away with this one here. I don't need that one right now. And it is just printing out the message, but it can't handle the problem. It is just, let's say here I redirect this message, which is here thrown in this one, just to the server. And then I say, okay, this catch block has no clue how to handle it. And instead of using now std exit, which I could make normally when I have no clue how to handle it, and I'm not sure if I should go on or not, you can say, okay, throw again. And another level of try catch block should try to solve this problem. What happens here is now this throw will continue like it was thrown from here and skip this catch block here, which means it will jump to this catch block and this catch block will try will try now solve it because it's thrown here again. Because if you don't throw it here, this catch block will handle it and then it goes back to the normal work to the normal flow, program flow. Let me show you without flow fast and then with throw. And let's write some little bit more text so we see what happens here. Let's make this one more. Let's copy this one. Let's paste this in and let's write here perhaps something like so. Here I write let's say here, what is that? This is function one test. Function test one. Okay. function test. Oops. Why is that so strange? Function test. Oops. Function test 1 can't solve this exception. So exception. Rethrowing the exception for other try blocks. All right, we will get this one here, but in this case I'm not rethrowing it. In the next case I will rethrowing it. Okay, let's make it this way. Oh, later I make this one here. So when I start this program here, let me show you what happens first and then we go through it. So you can see here the function is, yeah, let's see what happens here. So here the function is called, it's better to go with the debug, then we see it faster instead of going here step by step. So you can follow it much easier. So let's start this one. And here I'm in my function again. I go in for function 1 test. I go in, it's create the variable, it goes to function 2, it jumps there, it jumps here, it jumps there, and now it's interesting. From this point it's interesting because now I throw an exception. Anything strange happened. All right, let's see. It is jumping to function test 1. Why it is jumping here again? First of all, let's repeat it fast. This is a string type. The string type means this throw searches a catch block. It tries to find here, no. It tries to find here, no. It tries to find here, yes, because it was tested here with this one, the start of the test, and that's why it can jump here. And it is jumping here to this catch block here. And this one has the same type, that's why it's possible. And you can see it will execute now this line of code. And after this line of code, what happens after this one? The normal program flow. What is the normal program flow? We will see it in a moment. The normal program flow is it will jump to this line of code, which we expect because here it is just going to this one here. Let's see if it's true. And we are jumping first out of this block. Yes, that's the, oh, sorry. The normal program flow is that it jumps out here and then goes here. Okay, one more step was it. It jumps here to this normal flow and then here from this point, function 1, it goes back here to this point. All right, here we are back to this point. Now, this one will be executed, which means we have executed this one first. Now we execute this one here second. And then you can see it jumps up there, it goes there. Then it will execute this one here. So you can see that was the second text and now it executes this one. All right. And then let's see this one here fast too. So you can see this one. And then we have our program flow. And here I have again a text, which means this try block here has no error. The error was handled. Oops. Let me show this one. That sounds a little bit strange, because the arrow was handled here on top. This try block has no arrow, which means this one is not activated here. That's also a little bit strange, and that means the program flow from here is jumping actually here. And when I show you this one, when I jump now here down, you will see it will jump here. Bang, it is here. And you can see, oh, one more line. Now you can see we have here this output. And then it returns, the program terminates normal. One more word I forget perhaps that to say. This terminates here is important also for the operating system to indicate that this program returns successfully. And when you have something like an exit, like I wrote here, that is not even indicating the operating system that this program terminated successfully or not. It's not really, let's say, it's not really telling anything useful. But the operating system will automatically still clean up all those resources on its own definition. But that's a side note. That's not so important right now to understand. Right now to understand, it's more important what happens now. I use now my throw keyword. Let's uncomment this. Uncomment. And what I said is throw again means it will jump in here, but this one can't handle it. Let's say you can see it says here function 1 can't solve this exception. Rethrowing the exception for other try blocks because I can't solve it, but I can throw it again so other try blocks can solve it. In my case here, the other try block would be here, the last try block. Of course, you can make in every function a try block, and then you can see which one can solve it. If nobody can, then it will end up like mice with this exit. Exit means the programmer should come and check it on its own. What's the problem is. And if it can solve it, means the programmer don't need to come. It is solved internally anyhow, and the program can go on. But still, there will be still an error message for the programmer, even if it's go on. But the programmer has not to come actually to solve this one. At least not immediately. So let's see what happens. I talked too much, but now let's make this again with this debug, because it's better that I start debug instead of talking so much and showing this one. Here the debug is showing it much better, I think. Then you can follow it easier. So let's see what happens. I go in, the function is called, right? Function 1, I go in function, I go in the try block, the function the test2 is called. I'm here in function test2, and then I go in, now I call function test3, and I go in, now I'm in function test3, and now it becomes important. Here is the throw block here, we can see, and now let's see, I press, and what happens again? The throw is searching for a catch block, and it is finding one catch block, and that is our function test1, because I tested this here. But don't be irritated, I test here function 2. Function 2 is here and calling this one, and the reason why this is still jumping here is just because this one includes test of function 2, and these are all its members more or less of function 2. That's why this one is still catching here. Anyway, it is catching. Normally we are happy because it is catching. Catching means this throw is solved, and after this catch we expected it that it exit the code here, this program here terminates, or it is continue with the normal workflow. And look what happens now. I go dive in, I have now here this information that was this line here, and now I dive again in. Now I have the second information that was this line here. It says here function 1 here, this line here, can't solve this exception, rethrowing the exception for other try blocks. And now we are at our throw block, and we go in, and you see this throw block is exactly doing that what I said. It takes the object and it's just throwing again for another try block, if there is any, of course. And if there is no any try block, we have a problem, because this stuck unwinding, which I talked before, can't happen, and these resources can cause problems, and so on and so on. But that's there we will dive into later even more, not in this video and not in the future, because we will finish first the basics when you get a little bit better. So here what happens now? This one refroze it. We are where we are here in the second catch block, because this function 1 test is also tested here, right? And because it is tested here, I have here this catch block which matches which type again? Here is no type, but like I said, it is rethrowing the exception type which was caught here, which means it is exactly rethrowing this type here. So you know it is rethrowing this type, which is string, and this information, and means I have this one. That's why we have here this string type here again. And here this is my last place where I can try to catch it before for example, before I say it's time to shut down this program. We can't solve it and it's too dangerous to go on. Or I can say it here, what I wrote here. If it's on a plane, you would not shut down the program. That's too dangerous to shut down the program. But if you're on a server, you can stop here, because the servers has most time backup servers, which means at this point a backup server should start, and this server should be shut down till this problem is solved. And yeah, I go in, and here I dive in, and this one indicates only that I'm finished. The program is finished, it can't go on. Right, that's it with our try catch block. Also, I think there is still much to talk and so on, but if you understand, some of this one is good. So we have not talked about many constructors, destructors, and we have not talked about the most important part, not the most important part, but one of the important part, which is we should normally use not something like that what I showed you all time here, which is what I showed you all time here, this random where is that? Here, this random types here, catch clauses. I showed you all time this random type created types, but it's also good to know how to create them. But normally you should not do this. Normally what you have to do is use, you will see it, you should use this exception class. But I wanted not dive now into exception class. I can open this one. We have to know a little bit about classes, and then you have to use this exception class, and then you have to use how you can expand that, or yeah, we have to talk about classes, and that's the reason why I skipped this. We will talk about exceptions again, but not so fast again. First we cover here more keywords. We are almost finished here with our repetition. We have here some only little left, and then we continue with our regular keywords, and soon we will learn classes. And when we learn classes, then in future we will talk about exceptions again, because then you know why we should use exception classes. In just short form, exception classes are predefined classes which you should use, and if you can't use them, you normally inherit from these classes, which means you extend just the codes and then still use them and so on. Anyway, we have to talk still there a little bit, but important is if you understand this codes what I made. Let me give you one last word, which is probably the most important for starters. If you understand nothing till now, no problem. The reason for that is these are just a test of code, more or less, and you can solve this kind of stuff other way too. You don't have to use exceptions, like I said here. Not here. Here you can try to solve this kind of stuff also with just if tests. Where was it? My if here. I make here if test, and then I can react with a if test too. But yes, we will talk about this later more, because there are error codes, something like that. You can create error codes instead of exceptions and so on. And yeah, so don't worry if you understand this exception is anyway very complicated. But if you understand this workflow, you can use it, and you can make your code more, let's say, safe. But you have to read a little bit online more about exception, because there are books about exception, because there are pros, there are contras, and there's so much to consider. It's not easy, let's say, because there are so many different cases where how the program went wrong. So you have to decide, and you have to know how to decide, and all this kind of stuff. Don't worry as a starter, just understand the core concept, and the core concept is really try one code. If it throws something like that, then you have to know this type, this value, and it will catch it, and it will only catch it if it matches this type. And we have here the different versions here, without names, with name, without name, or with just ... which is just any type. And if you understand this, that's okay. And later you understand more and more when you make real examples with exceptions. So that was the last thing about our try catch block. It was a long video again because I tried to demonstrate this code. There's still much to talk, but I skip now all other things. We are continue with our repetition, and we are soon finished with our repetition, so don't worry, we are here. Try, and we have only this, so 3-4 words, 3 or 4 more words, and then we are finished. All right, with that said, if you have any questions, any complaints, any tips and tricks, write them in the comments. And I hope you get better. Good luck, don't give up, and see you in the next video. Bye.